Hello, and welcome to B-LISP. No, I'm not going to do the whole thing like that. Anyway, this is just a recording of kind of my start on B-LISP, which is just a project to implement, a very traditional Lisp. I prefer traditional Lisps in a game creation platform called Blitzmax, which I slapped down $80 for. Gosh, I don't know, maybe sometime around 2005 or so. But anyway, it's an old bit rotten thing. It's kind of a, I don't know, kind of a Pascal-ish type basic language. Anyway, it's just like everybody implements Lisp and C. That's tired. It's done. Or C++. We got one or two implementations there. But really, if you're going to infect the world with Lisp, you need to be able to implement it in all kinds of crazy stuff. So maybe someday somebody will put it in Visual BrainSick for applications, and then we can shove it into Excel and have a real programming language there on top. But anyway, I kind of want to show like the graphics functionality so far. So I'm just tinkering around wrapping graphics functions in Blitzmax. The nice thing about that is you get this stuff for free, and you can call it from Lisp once it's properly wrapped. So you have things like draw rect, right? You get basically the Lisp primitives in there, and then you convert them to integers. Of course, we have the car and the cdr, the second, and the third and the fourth, these are going to be your points that get passed in. I'm using NAND boxing in here, so we're basically abusing the number system to break the type system, so we get dynamic typing out of a rigidly type, out of a static type system. I don't really prefer static typing. I think it's too much decision up front. And generally I'm a competent enough programmer that I don't get myself into too much trouble just because I'm really careful with naming things. I say that now and then watch me get into trouble over here while I do the demo. Anyway, this has gone on long enough. So let's start a graphics window, right? I've hijacked the graphics functionality in Blitzmax. There it is up there. So it takes a width and a height essentially. And eventually I need to come through and comment these things better. But for now, we'll use the sacred resolution of 640 by 480. So we'll get a graphics context. And of course, we're still in Bash. So let me clear this and start the B REPL. Okay. Do note it's not 1976. That's for stylistic reasons. So anyway, we'll do graphics, the holy resolution of 640 by 480. That'll give us a graphics context, and I'm going to pin this on top. This is a great option in operating systems that don't have Fisher-Price window managers. You can pin them on top, and they stay there. So now what we can do is we can use some of the built-in wrap functions. So there's like set color, and it takes 3. Blitzmax actually supports transparency, but for now I've just done 3 colors. If I was using straight Blitzmax, then I would have like a blending mode too. It has like it's a pretty cool little system. So anyway, everybody uses red, and I'm tired of red, so we're going to use orange, which is just as easy to make. It's half on the grain, full red, and no blue. So we're going to set the color to that, right? And then what we want to do is we'll do something like a draw rect. I think that's what I call it. Yeah. Okay, and that takes 4 points. So we'll do like a 32, 64, 128, and then 256. That'll give us a thin, tall one, I think. Okay. Now it doesn't appear because you need to flip the buffer. And when you do that, it spills it onto the screen. And Blitzmax, being made for games, can handle this at 60 frames per second. The hesitation you see in my REPL here is because it's being interpreted. Eventually, I'd like to get it compiled. But for now, we're just in interpreted mode, and it's also doing all these specialized print functions to give me constant feedback, unlike the internal representation of this sort of thing. But eventually, I would like to have it fast enough that I can write games in this and then, render in almost as fast as Blitzmax. And Blitzmax really is about on par with maybe C, maybe a little bit slower, but it's an old compiled language, and it used to be that you'd have all these basic game engines literally written in, for basic like languages, and they would run just as fast as they're compiled, so they'll run fairly fast. Everybody thinks, oh, you gotta use C, you gotta use Rust. No, you gotta use C++. I mean, there's game creation systems like this that are perfectly fast enough to do what you want to do. Although this is an old bit rotten thing, and I don't know, at some point I'm going to have to sandbox this probably, but I plunked down my $80 for it somewhere around 2005, so I'm getting my mileage out of it. Anyway, so we'll do a CLS, which is going to clear the screen. Of course, I need to flip the change in and do that graphics context. So wouldn't it be nice if we had a way to do a random color? And again, this BlitzMax program is continuing to run, right? But I can still, in my REPL over here, define new things. So B-LISP is a very traditional Lisp, so I've kept the defen, but you can also do define scheme style. I've kept the option open for either one of those styles. But we'll do rand color, right? And it's going to take well, it's going to have no parameters, so we'll have an empty parameter pack. But what it needs to do is call set color, and then we're going to go times the max value 255 and then a random value. Right now random is just between 0 and 1 with 1 exclusive. So we can do this, and really this is kind of a bad thing. It should be called, you know, set rand color, but I got one line here because because right now this REPL isn't advanced enough to handle new lines, so we're just gonna have to keep typing everything on one line, but that's fine. And we'll call random once more, and of course, thanks to Emacs knowing how parentheses work, we should have rand color. Yep. So we got an atom back rand color, and it, basically I have another function, atoms family, and this shows you all of the currently defined functions, all the currently defined functions in the system, and you can see rand color is actually a closure. Functions are represented by closures, of course, in B-LISP, but this is actually a little, oh, well, I guess I need to look into that. Anyway, let's do it again here. All right. Rand color, no parameters. Sorry, that's the way it is. 255. Again, you know, when this becomes a little bit more polished, I'll have more error handling, but it really ticks me off. I thought I had atoms family solid, but all right. Graphics, holy resolution of 640 by 480. All right, we'll pin this back on top. All right, we're back in business. Sorry about that. So now we can do rand color. That'll set a random color, and then we can do draw rect, and we'll do 32, 64, 128, 256, and then we'll flip. All right. And for some reason that's white. Let's look at, see. Ah, yes, we actually need to set the color here. Now let's try. Oh, did we not flip it? There we go. So we just weren't flipping it. Duh. Okay. So now what we want to do is we want to have a function for a random rectangle, right? Then we can make some random rectangles on the screen. So we'll do that. Actually, let's do it the scheme style. I said it supports the scheme style. We'll do it that way. Round rect, right? Not going to take any parameters, and it's going to be draw rect times 640. And this would be a point that you abstract this stuff into something a little bit nicer, like rand width, rand height, etc. But since I'm doing this live, we won't do that today. Again, you know, when you think about building a language around your project, it significantly shrinks your code and makes your intent a lot more clear. People will whine that you have to jump through a bunch of functions, but welcome to abstraction and programming, and you know, programming actually being a multi-level thing. It's not a flat data structure so much, not even flat syntactically either. Okay, and we'll get random in here. That should be, yeah, let's see. So now we can give this a try. Now remember that was defined the scheme way, and ideally if you're going to use this language, be consistent, but I wanted to allow both. So we'll do 128, 256. I don't know, 128 again. It'll be kind of, and then 256. It should be a squares thing. And now we have to flip. Okay, so we've got that. We've got rand color and we've got rand rect. So then we can do, I don't know, you can do like this. And you're going to get random values. And of course they'll go all over the place. I still need to implement a better garbage collector. Right now it just garbage collects once at the end of every loop, a REPL. Basically it saves where it left off and conses up all this memory, and then as soon as that iteration of the REPL finishes, it blows it all back. So yeah, still need to implement a better garbage collector. But anyway, I mean, implementing it in a completely alien language and hijacking the graphical environment. I should come up with a way to close this, because right now you can't. But if you enter quit in B-LISP, it'll kill everything off. So that's what I've got for now, and hopefully, I don't know if I'm going to keep this, keep it around forever. But the challenge was implement Lisp, a traditional Lisp, first and foremost, in something that's would be considered a very alien environment. The question is, what if I just had Blitzmax? Could I implement Lisp? How would it be different from the C implementation? And the reference implementation I'm using for this is actually Tiny Lisp, which is like Lisp in 99 lines of C. And then I've kind of gone off on my own way, and I've done a substantial chunk of that paper. But anyway, yeah. So basically hijacking the functionality of an underlying language, exposing that through Lisp primitives, and then having a REPL that you can call it in real time. So that's it for today.